+1. You are given a large integer represented as an integer array digits, where each digit is the ith digit of the integer. The digits are ordered from most significant to least significant in left to right order. The large integer does not contain any leading zeros. Increment a large integer by 1 and return the resulting array of digits. There's 3 examples. The first one is 1, 2, 4 because the array represents the integer 1, 2, 3. Incrementing by 1 gives 123 plus 1 is 124. Thus, the result should be 1, 2, 4. The second one is 4, 3, 2, 2 because the array represents the integer 4, 3, 2, 1. Incrementing by 1 gives 4, 3, 2, 1 plus 1 is 4, 3, 2, 2. Thus, the result should be 4, 3, 2, 2. The third example is 1, 0 because the array represents the integer 9. Incremented by 1 gives 9 plus 1 equals 10. Thus, the result should be 1, 0. Constraints. 1 less than equal to digits.length is less than equal to 100. 0 less than equal to digits is less than equal to 9. Digits does not contain any leading zeros. I'm using Python for the solution, and let's do it. The code defines a class solution with a method +1. This method takes a list of integers digits as input and returns a new list that represents the original list, incremented by 1. In the +1 method, a variable num is initialized to 0. It will be used to calculate the numeric representations of the digits. The code then iterates over the digits list using a for loop. For each digit in the list, it calculates the corresponding numeric value by multiplying the digits with the appropriate power of 10 based on its position in the list. The calculated value is added to the num variable. After iterating through all the digits, the code converts the incremented number num +1 to a string. It then iterates over each character in the string, converts it back to an integer, and creates a new list with the incremented digits. Finally, the method returns the new list, which represents the original list incremented by 1.